All right, guys, you guys had the opportunity to work on this speed, distance, and displacement practice packet. I'm going to go through a few of these examples. The ones that I don't go through the examples, I will go ahead and just tell you the answer. You'll have to solve that problem. However, if you would like to go through that with me at any time, just make sure you shoot me an email or come on in and we can go over that, okay? So, use the graph paper to draw each scenario. I'm not going to ask you to do that. Fill in the correct information and distance for displacement using the correct units. Again, I'm not doing that. Here's an example. Distance is 4 meters plus 2 meters, and that's 6 meters total traveled distance. Displacement, though, look, 4 meters plus 2 meters, but distance and displacement's different. Let's say you've got a garage right here, okay? And your driveway is 10 meters long. That's a short driveway. Whatever. Okay. Your car is in here, and you take your car and you go out, you go to work, and then you come right back in. Okay. Let's say work's right here. Your total distance is the total amount that was traveled. So you're going to exit to go to work, 10 meters, 10, you're really close to work. And you go back in. So work then would be 20 meters. However, displacement, you're pushed away, okay? You're kind of turned off to it. But it's just how much you're actually moved from that original location. Now, if I asked you your displacement between home and work, it would be 10 meters. But if I asked you your displacement at the end of the day, you went to work and then you came right back. So your displacement would actually be 0. Okay, so I want you to remember that as we are going through this. So, you need to remember your directions when we go through this. Never eat soggy waffles, okay? So first what happens, your first move, you move 4 meters east. So you're moving 4 meters this way. And then you move 2 meters west. All right, well, which way did you travel more? Traveled more to the east by how much? 2. How much did you travel total, though? 4 plus 2 equals 6, okay? Same idea. You move 4 meters north, so 4 meters north, 2, 3, 4, okay? You move 2 meters south. What is your total distance? 4 plus 2 equals 6 meters. What is your displacement? Which way did you move more, north or south? You moved north, okay? So you know it's going to be north. By how much more? 2 meters. All right, same idea. You move 2 meters east. 1, 2. You move 4 meters west. 1, 2, 3, 4. What was the total distance? 2 plus 4 equals 6 meters. How much did you move one direction or the other? Did you move more east or more west? Well, you moved 4 meters to the west and 2 meters to the east. So that means you moved more to the west. But by how much? 2 meters. All right. Last one I'm going to do for you is this. You move 5 meters east, and then you move 5 meters west. Ooh, what was the total distance you traveled? This is a lot like our garage analogy. You moved a total of 10 meters. But in terms of displacement, remember, it's direction and how much you actually moved from that initial location, first point to your last point, okay? So we moved 5 meters east and then 5 meters west. We moved 10 meters out and then 10 meters in. Our displacement is 0, okay? And I'll do one more. We move 5 meters south and we move 2 meters north. 5 meters and 2 meters. What was our total distance? 5 plus 2 equals 7 meters. Our displacement, did we move more south or north? South. By how much? 3 meters. Exactly right. All right, let's go ahead and flip to the next page. I'm going to go through some of these with you, not all. All right, we have A truck that travels to and from the stone quarry that is located 2.5 kilometers to the east. What is the total distance traveled by the truck? All right, well, the truck traveled point A, point B, to, and from. And we know that it's 2.5 kilometers, and this is on the east, and this is on the west. 2.5 plus 2.5 gives us 5 kilometers. What is the displacement? Well, it started at point A, and he traveled to point B, and he went 2.5 kilometers. And then he went from point B to point A and traveled 2.5 kilometers. Did his original place from A change? No. So it's 0 kilometers. Exactly right. Alrighty. Number 2. A whale swims due east or directly east for a distance of 6.9 kilometers, turns around and goes due west, so directly west, for 1.8 kilometers, and then finally turns around again and heads 3.75 kilometers due east. That's a lot, okay? So let's draw a diagram. We've got north, never, eat, soggy, walks, okay? So, first things first, he starts in the middle. Always assume they start in the middle, okay? This is point A. So, swims directly east for 6.9 kilometers. This is point B. Then he turns and he goes west for 1.8 kilometers. Let's call this point C. Then he turns around and goes back, draw this a little longer, 3.7 kilometers. Whoa, that's a lot. So, what was the total distance traveled by the whale? So, what we would do is we have to add these together. 3.7 plus 1.8 plus 6.9. That gives us 12.4 kilometers. What was the total displacement, though? So, let me draw this a little more simply. First thing that we did was we traveled this way. Let's draw this a little longer. 6.9 kilometers. Then he traveled back this way 1.8 kilometers. And then from that point, he traveled back this way and went 3.7 kilometers. Which way did he go more? East or west? He went east. Exactly right. Then you could visually solve this problem, or what you could do is you could say not 6.9 kilometers minus 1.8 kilometers, okay, and that's going to give you this point. And then we add 3.71 kilometers. And what we get is we get 8.8 kilometers, and don't forget that distance, east. Alrighty, number 3. A football coach paces back and forth along the sidelines during the rivalry game. The diagram below shows several of the coach's positions and various times. At each marked position, the coach makes a U-turn and moves in the opposite direction. In other words, the coach moves from point A to point B to point C to point D. What is the total distance the coach traveled? Whew, that's a lot, okay? So we have, first things first, he started at point A, okay? And then he went to point B. So that was the first step. Okay, so we went from 50 to 10. Or 50 to 15. So that would be a total of 35 yards. 5, 10, 15, 20, 25, 30, 35. Okay, so that was the first one. Then he went from B to C. From B to C is 20 yards. And then he went from C to D. C to D is 40 yards. So, first, he went from A to B. Then he went to C. Then he went to D. What is the total distance? Well, that's the easy part. We do 35 plus 20 plus 40. Easy peasy. That's 95 yards. But what is his total displacement? From point A, did the coach go more to the left or the right? More to the left, okay? So we know that final answer is going to be to the left, but by how much, okay? We know that he started here. This was point A, and this was his final point. Well, this is the easy part. We just got to count. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55. So his total displacement was 55 yards to the left. Okay? Alrighty. So, I flip this over. Number 4 can get some people stuck, okay? I want you to imagine we have 2 cars that start at the exact same point. So I'll draw 2 really sad cars. Give them some wheels, okay? And they drive in a straight line for 5 kilometers. Both of them are going to drive in a straight line. At the end of the drive, their distances are the same, but their displacements are different. Explain how this could happen. Well, we know distance is the amount that's traveled, but displacement is the amount that it moved from point A to its final location and its direction. So what that means is this car could go 5 kilometers to the right, and this car could go 5 kilometers to the left. Alrighty. So number 5, you guys can solve for speed. I'm going to let you guys solve that yourself, but the final answer will be 10.32 meters per second. Number 6, we've got, again, we're determining the average speed. Remember, speed is equal to distance over time. So I'll do this one with you. In the funny car competition at the Joliet Speedway in Joliet, I don't even know if this place exists, in October of 2004, John Force completed the quarter-mile dragster race in a record time of 4.437 seconds. What is the average speed of the dragster? So we know speed equals distance over time. Here's the distance. Here's the time. So we just do a quarter of a mile over 4.437 seconds. And what we get is 0.056 miles per second. Now, I am going to do number 7 with you because we have not quite gone over velocity. So I want to teach you guys how to do velocity, and then I have a lesson that's coming up that we will go over this a little bit more. So what I want you guys to understand is that velocity is equal to displacement over time. Speed, however, is equal to distance over time. Very different. Could be the same answer, could be a totally different answer. But the way that you guys are going to be able to tell the difference is with velocity, I give you the direction. We are solving for velocity, okay? So Lance Armstrong starts 150 meters north of Paris and is 500 meters north of the city after 30 minutes. Determine the average velocity in meters per second. Okay, well, let's check our units. We've got meters, but we don't have seconds. So first things first, we need to convert minutes to seconds. Well, how many minutes are in a second? How many seconds are in a minute? 60 seconds is equal to 1 minute. So if we're going to convert this, we would take 30 minutes. And what do we want? We want seconds. What do we want to get rid of? Minutes. So we know that there's 60 seconds in 1 minute. Okay? So 60 times 30 gives you 1,800 seconds. Okay? So that's the time. But we still have 150 meters north. And then after 30 minutes, he's got 11,500 meters north of the city. Okay. Well, we just need to add those two together. That's all we got to do because they're both going north. So what you would do is you would say velocity equals the displacement. The displacement's going to be this much plus this much. So 150 meters plus 11,500 meters, remember that direction, over 1,800 seconds. When we add those together, we get 150 plus 11,500. That gives us 11,650 meters north over 1,800 seconds. 11,650 divided by that number gives us 6.47 meters per second north. That was hard. All righty. Number 6 is a little bit of a challenge problem. I'm going to let you guys do that on your own, but I do want to encourage you guys to come and see me if you have any questions, okay? This is one that I will not have something quite this difficult on your guys' final assessment. However, if you can do this, you really should feel confident in your abilities, okay? And you can pick this block. All this means is, let's say I'm going to make it, because these are all in hundreds kilometers, I'm going to make each block 100 kilometers, okay? All righty. And last but not least, I'm going to let you guys finish the rest of these. If you would like to come and see me for any extra help, please come in and we can go over that. Thanks.